we now discuss the solution of a problem from the section Differential Calculus, and the problem is on absolute maximum and absolute minimum of a given function in a given interval. This question has appeared in Joint Entrance Examination Main held on 24th June 2022 in the first session. The problem is the sum of absolute maximum and absolute minimum values of the function f of x is equal to modulus 2x square plus 3x minus 2 plus sin x cos x in the interval, closed interval 0, 1. We are given the four options. Option A, and we have option B, option C, and option D. And we are given this function, and this function is defined in the closed interval 0, 1, and we have to find the absolute maximum and absolute minimum values of this function and sum it up. And we have to find the sum of the absolute maximum and absolute minimum values of this function in the closed interval 0 to 1. We now discuss the solution of this problem in detail. We have the function, and this is factorized. 2x square plus 3x minus 2 is equal to 0 is factorized as x plus 2 into 2x minus 1 is equal to 0. And we are equating to 0 and finding the roots of this. And x is equal to minus 2, x is equal to 1 by 2. We reject x is equal to minus 2 because minus 2 does not belong to the domain of this function. That is, it does not belong to the closed interval 0 to 1. And why are we doing? To know where the sign is changing for this function 2x square plus 3x minus 2. So sign changes takes place in 0 to 1 by 2, 1 by 2 to 1. So now f of x is equal to, and this factorization mod of x plus 2 into 2x minus 1 plus sin x cos x is 1 by 2 sin 2x. X belongs to 0 to 1 by 2, 1 by 2 open, 0 is closed, union closed interval 1 by 2 to 1. And now for all x belongs to 0 to 1, x plus 2 is always positive, therefore you can take out, and that is equal to x plus 2 into mod of 2x minus 1 plus 1 by 2 sin 2x. X belongs to this first subinterval and the second subinterval. And we discuss this in detail considering two cases. Case 1, let x belongs to 0 to 1 by 2. Then in this interval 2x minus 1 is a negative. Therefore, mod of 2x minus 1 will be minus in brackets 2x minus 1. Then f of x will be minus x plus 2 into 2x minus 1 plus 1 by 2 sin 2x. And when you multiply, you will get minus 2x square minus 3x plus 2, 1 by 2 sin 2x. And to find the maximum value and minimum value of this function in this subinterval, we have to talk about its first derivative, and if it is greater than 0, it will be increasing, it will be less than 0, decreasing. If increasing or decreasing, then we can find maximum, minimum of this function in this subinterval. So take the first derivative, f prime x is equal to minus 4x minus 3 plus 1 by 2 into 2 cos 2x, 2 cancels, minus of 4x plus 3 plus cos 2x. Now, note that in this interval x belongs to 0 to 1 by 2, 4x plus 3 will belong to 3 to 5. When x is equal to 0, it will be 3. When x is equal to 1 by 2, it is 5. 3 to 5. And half 1 by 2 is open at 1 by 2 end, therefore open at 5 end, and closed at 0 end, therefore closed at 3 end. And this will imply minus 4x plus 3 will belong to, it will be get reversed, minus 5 to minus 3, closed at minus 3 end. And what about cos 2x in this interval? So x belongs to 0 to half, cos of 2 into 1 by 2, cos 1 less than cos 2x less than cos 0. Why? Cos 2x is decreasing in 0 to 1 by 2 and in fact it is decreasing in 0 to pi by 2. Therefore it is decreasing in 0 to 1 by 2. That is why it is get reversed. Now cos 1 minus 5 plus cos 1 less than minus 4x plus 3 plus cos 2x less than minus 3 plus 1. So this will be x belongs to 0 to half, minus 5 plus cos 1 less than minus 4x plus 3 plus cos 2x less than minus 3 plus 1. And this is nothing but f prime x. That means f prime x is less than minus 2. That is, it is negative. F prime x is negative for all x belongs to this interval. Therefore, fx is decreasing in this interval. So, it is decreasing means it will be like this. It will be like this. So, when it is decreasing, the maximum will attain at 0. The minimum is attained at 1 by 2. So, f max is f of 0. When you substitute f of 0, it will be 2 only. And f min is f at 1 by 2. Substitute x is equal to 1 by 2 in this. Then you will get 1 by 2 sine 1. This will be 0 because 1 by 2 is a factor, is a root of it. So 1 by 2 sine 1. So like this we will also discuss for the case 2. We now take, let x belongs to 1 by 2, 1. So in the case 2, we consider this. In this interval, 2x minus 1 is greater than or equal to 0. Therefore, mod of 2x minus 1 will be 2x minus 1 only. And therefore, f of x will be equal to x plus 2 into 2x minus 1 plus 1 by 2 sine 2x. When you multiply, you will get a 2x square plus 3x minus 2 plus 1 by 2 sine 2x. And first derivative, f prime x is equal to 4x plus 3 plus cos 2x. Now, note that x belongs to 1 by 2 to 1. Closed interval 1 by 2 to 1. F prime x will be 4x plus 3 plus cos 2x is greater than 5. Greater than 5. So, f prime fx is increasing in 1 by 2 to 1. Why? Because f prime x is greater than 5. Fx is increasing in this interval. So, if it is increasing, minimum is attained at 1 by 2 and maximum is attained at 1. So, f min will be f of 1 by 2, that is 1 by 2 sine 1. F max will be f of 1, that is 3 plus 1, 1 by 2 sine 2. So, substitute x is equal to 1 here. You will get 3 plus 1 by 2 sine 2. And this is already we have seen. Now, so we consolidate now. So, we discuss. So, in the first interval 0 to half, this is the one, f max is 2, f min is 1 by 2 sine 1. And in 1 by 2 to 1, f min is f of 1 by 2, that is 1 by 2 sine 1. F max is f of 1 plus 3, that is 3 plus 1 by 2 sine 2. So, now what we see is 1 by 2 sine 1 is less than or equal to fx for all x belongs to 0 to 1. 0 to 1. So, 1 by 2 sine 1 will be absolute minimum for the fx. Therefore, absolute minimum for fx is 1 by 2 sine 1 because 1 by 2 sine 1 is less than or equal to f of x for all x belongs to this. Therefore, it is a global minimum. So, that is absolute minimum is this. And also, f of x is less than or equal to 3 plus 1 by 2 sine 2. that is between, this is the highest value. So the 3 plus 1 by 2 sine 2 for all x belongs to 0 to 1. Therefore, this is absolute maximum. Therefore, absolute maximum of fx is 3 plus 1 by 2 sine 2. Now, the question is the sum of the absolute minimum and absolute maximum values of fx. So you have to add these two things, and that will be 1 by 2 sine 1 plus 3 plus 1 by 2 sine 2. So 1 by 3 plus 1 by 2 is taken common. That will be sine 1 plus sine 2. For sine 2, we have written 2 sine 1 cos 1 to get an answer, to get the form of the answer. So we take sine 1 common, and that will be 3 plus 1 by 2 sine 1 into 1 plus 2 cos 1. Let's look at our options. Our answer 3 plus 1 by 2 sine 1 in brackets 1 plus 2 cos 1 appears against option B. Therefore, the answer for this question is option B. And that is the discussion of the solution of the problem on absolute maximum and absolute minimum of a given function in a given interval. I am sure that you have understood the solution of this problem, and go on working out problems based on maxima and minima, and it is very important. I wish you all the best. Thank you.